Hello everyone. Today I'm going to present smart plant monitoring for IoT class for Izmir Democracy University for my class. Uh, the IoT project is smart plant monitoring, which aims to monitor your plant's humidity level and temperature level from a remote computer or from a mobile device. So what I did in this project, I used Raspberry Pi picoW, which includes the Wi-Fi module also, and I used Arduino IDE to program the Raspberry, and I used Blynk IoT tool for communication to remote devices. So let's go through my code. Yeah. To use Blynk on your project, you need to first define your template ID, template name, and Blynk authentication token. Then you need to include Wi-Fi that you're gonna use for your device, and you need to include Blink Simple Wi-Fi module to use it in your Raspberry Pi picoW. If you are using something like ESP32, there are different libraries like Blink Simple ESP32 Wi-Fi or different. I used DHT11 module, which can monitor humidity and temperature levels by setting up circuit. And I used a servo motor, which controls the watering system that later gonna water the plants automatically or controlled by your remote application or remote device. Then you need to add your Wi-Fi credentials to the board, which board needs to connect your Wi-Fi to enable communication to a web server. Then I have defined the virtual pins. Virtual pins is pins that the data will transfer to your IoT server. For example, in here, humidity pin, V0 pin transfers the humidity values to remote billing server via V0 pin. Uh, the remaining configuration is about circuit. I have defined the HD pin as pin 2, which is second pin on the Raspberry Pi picoW. And I have defined my DHT type as DHT11. You can use the HT22. It's also different one from this one, but the logic is similar. More new one. Uh, then we are defining the HT. Then I have added three LEDs, which red represents the humidity is really low, and green is humidity is okay, and blue is for the really high humidity. And I have defined my server, and I have connected the LEDs to red to pin 6, green to pin 5, and blue to pin 4. I have added servo motor, which will control the watering system to pin 9. And we are defining the servo. And I have defined some threshold levels that will activate the servo when the humidity is below 40% or will close the servo when humidity is higher than 70%. Let's look at setup phase. In the setup phase, just for the debug purposes, I have added serial prints, which you can see under the code in this section. Uh, as you can see, last printed humidity is 30% and temperature is 24.30. And I have printed the initial print that to confirm the serial is working. Then we are starting DHT begin, and we are setting pin modes of LEDs to output to control the LEDs. Then we are attaching servo, and we are writing angle degree to servo, initial angle degree, and we are starting the Blynk server by Blynk begin function. In the loop section, which will always run, we are running Blynk run, which Blynk run function is sending the virtual pins that I earlier mentioned, these virtual pins to the server. Uh, and at initially, I am blinking the onboard LED just to check the board is alive or not. We can remove this code. It's not that important. Then we are reading humidity from the HT sensor and we are reading temperature from the HT sensor using these functions. And this is a redundancy check if something failed. This is a debug print. And also I am printing humidity and temperature levels to the console just to see it from here. Uh, then we are writing Blynk pins, virtual write, humidity, temperature, and in the logic side, we are checking the humidity level. If humidity is below 40%, we are making the red LED on, uh, which will glow red light on the device. And if we are also writing these values to Blynk server. And if the humidity is normal, which is less than high value, high threshold, we are lighting the green pin as you see in this code, and we are closing the servo. In the previous condition, we were activating the servo, which will act as a valve from watering system, which will water the plants, and we are checking the if humidity is high enough, we are closing the servo. And the other condition is humidity is really high. Uh, in this condition, we are glowing the blue pin. Actually, it's not blue on my circuit. It's orange, but I couldn't find the blue light, so I had the orange, and we can change it. Uh, and we are also closing the servo to 0 degree, which there is no watering. And we are also uploading the data to Blynk server. So let's try to flash this example to the board. What we need to do, we need to press a button on the ESP32 circuit. Let me try to show you. This is my circuit, and there is a pin near to, sorry, a Raspberry Pico W. Let's press that button and connect the board to the PC. Now connection is done. We can check it via device manager. Let's wait a little bit to see device manager. In the device manager, we can check the device as we see in here. It's app mode, and we need to see the Raspberry Pico W that is connected here. Let's try to flash this one. We are pressing upload button. It first compiles the sketch, which is this code. It's now compiling. Let's wait a little bit. If there are any errors during compilation, we need to see it on the output section of here. As you see, compilation is gone about to complete, and it's scanning for the device and it's flashing the device. Currently, the LED is off. and the hardware got resetted. We will see the LED glowing. Oh, sorry. Yes, now is hardware is resetted and LED is glowing, which means the code is uploaded and board is now running. Initially, we set the servo as 0 degree, and currently we are monitoring temperature values from the environment as 24.6 degree and humidity is 37%. What I am gonna do is I will I will blow on the sensor to just to increase the sensors. Let me show it like this. Sensor is right here. I will blow on the circuit and I will try to increase the value on the serial monitor. As you see, uh, sorry, maybe you didn't catch it, but now temperature humidity level is more than 40%. It's actually gone to to 80 something percent, and it's now orange LED is glowing. I don't know if you can see it. Yeah, you can see it now. Let's wait a little bit that the humidity will go down automatically. I think it will take some time. I blew out a little bit too hard on the sensor. Sorry about that. Yes, now it's dropping down and the temperature is also dropping down. Now the orange LED is glowing. My ASP is right here. You will see below when we go below 70%, yeah. Now the green LED is glowing. Let's make me bigger and put my image on the screen a little bit more. Yes. Now green LED is glowing. Let's disconnect this from the PC and put it on somewhere. Disconnect and put it to the charger, which is not connected to PC, just for you to see that that this is an IoT device. I am disconnecting this and I am gonna put this device. Actually, I have charger here. Just a second. Now I am connecting charger to the cable, which device is not connected. Yeah, device is not connected to my PC anymore, but it is working. Let me show you. Uh, these values, yeah, we can see on the board, on the monitor that it's not connected. And we can, when we check here, there is no board. So this is running only from the power from charger. There is no connection to the PC. So let's go to the Blynk. In Blynk, uh, let me first disconnect just for you to see it. My plant monitor, I have arranged a plant monitor device. Let me disconnect it and you will see that it's gonna be offline in a minute. Hmm, let me refresh the page. Oh, it says it's still online, but no values updated. Let's go to devices again. Let's go to plant monitor and There is no power on the board, and it's still seen online. It's a little bit strange. Let's refresh the page again. Maybe there is a bug on the website, which is strange. It sees it still online. Anyway, let's try to reconnect the board, and I will show you the initial states of servo at the same time. I am connecting. Yeah, as you see, when the power arrives, it goes to 0 degree, and according to humidity, I will also show you. Now, uh, let's check the dashboard values. It goes offline right now. Maybe we need to wait like much more second to for it to be detected. Let's wait a little bit more. Now my circuit is online. Yeah, this is also online right now. So I will, how can I show you? What I am gonna do is I will make the blow again, and we will check the humidity level from screen. As you see now on my board, the LED glows green, and it's now orange, as you can see, and humidity is 78%. Let's wait a little bit more. I will try to show you the servo angle and the LEDs at parallel. Let me put my screen on top of the screen again, make it larger, and don't block the don't block the this one. Now LED is green, as you can see. It's also green on the IoT device, and I have prepared a mobile application, sorry, which I can also show you the same gadgets, same values that you can see the LED. Let me turn off my background blur. Uh, this is better. Yes. This is the application. Let me turn off the brightness a little bit so that you can see better. Probably you can see better now. Yeah. Uh, the same. Yes, you can. As you can see, humidity went down to below the 38%, and now the LED is red. Also on my circuit. Also on the PC. And just put down the circuit on the side and just put my phone and the background again. I will just blow the circuit again. Yes. Now, as you can see, uh, the LED on the board is glowing green, and my IoT devices are green now, all of them orange. Sorry for the inconvenience. Yeah, like this. Thank you. Thank you for listening. Uh, let's put this away. Thank you for the listening. This is all from my presentation of IoT device for plant monitoring system, IoT plant monitoring system. As I said, I have used an Raspberry Pi picoW. I have used three LEDs and a DHT sensor, a Wi-Fi module, which is already included in Raspberry Pi picoW, and uh, the IoT server, which transfers the data from device to web server, also to the mobile application. Thank you for listening.